Hey, how's it going? Today I'm going to be talking about stereolithography, SLA in other words, and what that is. Stereolithography, SLA, is a 3D printing technology that was one of the first methods developed for creating three-dimensional objects using additive manufacturing processes. It was invented which I don't know this person, and I don't know if it is an accurate information. I've done that in the past where I was looking who have invented some of those robots, and every time I was given different person's name, so I don't know if it's accurate or not. Is a popular technology for producing high precision, detail, and complex parts and prototypes. Let's take a look at the process how SLA works. Laser or light source SLA begins with a vat or liquid photopolymer resin. This resin is sensitive to ultraviolet UV light. A laser or other high intensity light source is used to selectively illuminate the resin surface, tracing out the shape of the object being printed, layer by layer building. This laser or light source moves into controlled manner, solidifying the resin layer by layer. The part is typically built from the bottom up, with each layer adhering to the previous one. Platform lowering. After each layer is cured, the built platform to which the object is attached is lowered slightly to make room for the next layer of resin. This process continues until the entire object is formed. Support structure. In SLA, it's often necessary to include support structure in the design, especially for overhanging or complex geometries. These supports are also made from the same photopolymer resin and are generated simultaneously with the object. Post-processing. Once this printing is completed and the object is typically removed from the build platform, excess resin is drained, and the part may require additional post-processing steps like cleaning, curing in UV light, and the removal process of the structure. Just summarize in my own words, that would be in something like a fish tank, and the lasers would print that part and give it a little bit more structure. Not necessarily in terms of durability, that particular method or and product would be suitable for to put any stress on finished part or project that you might be doing. You not necessarily would be able to put any stress. That would be perhaps different shapes and figures that you can put on a shelf if that's something that you might be interested in, because it's highly detailed work, highly, very, very detailed. It looks like great. All the I don't know if you were interested to build a dragon or something that would be 5 foot tall or 2 meters or something in the size of a dragon. You perhaps this particular method of doing that, just based on the detail, might be best suitable for that particular project that you not necessarily be able to use for anything other than looking at. If that's something that you're interested in. If you looking for nice figures that made from this particular material to have on a shelf, perhaps not limited to just that, but perhaps that would be a best printing method that you can adapt, or perhaps a small business, a side business that you can potentially generate some money from. We can touch on that a little bit later, but other than that, perhaps that would be one way to look at it. But if you perhaps be interested in building something that you can put on those parts a little bit more stress and they wouldn't necessarily break apart, perhaps not the best process to do it. SLA is known for its ability to produce parts with excellent surface finish and high accuracy. This is what it's known for, it's high, but there's pros and cons to everything, to whatever type of material you're going to be working, whatever technique you're going to be using. Some are better, but in terms of time, they're not the best. So depending what kind of problem you're looking to solve, right? It's commonly used in industries such as automotive, aerospace, healthcare, and producing designs for prototyping and small-scale production of intricate parts. However, SLA has limitations, including relatively slower build times compared to some other 3D printing methods, and the need for handling potentially toxic or irritating photopolymer resin. For those of you who like to structure your day and making most time of the day, we all have 24 hours, and what we like to accomplish with those 24 hours. What I did was, for many years, I have spent a lot of time reading on the how to develop a habit, how to manage your own time routines, how to structure that, and where to begin. And I have produced this particular tool. It's called Ink Flow. Within this tool, I'm sharing key areas that you should focus on, meaning 24 hours and making most of your time. If you would structure your routine, things to do, overall, some of the things that you're looking to accomplish, the goals, all those metrics would be structured around time. That's one of the best ways to approach it. I'm talking from experience. You're structuring your professional life, structuring your personal life. It's one of the best ways to approach this is by structuring around time. You can find this in the description below, as well as top retailers have it. Thank you. Stereolithography, SLA 3D printing is used for across various industries and applications to create highly detailed, accurate parts and prototyping. Let's take a look at some of the examples. Prototyping. SLA is commonly used for rapid prototyping in producing designs and development. Engineers and designers can quickly create prototype models and new products to test, evaluate their design before moving to mass production. That's potentially user case there, as well as dental models. SLA used in dentistry to produce high accurate detail models, including crowns, bridges, and dental implants. Jewelry. Designers use SLA to create intricate and detailed wax patterns for investment casting. This high resolution of SLA allows the production of fine jewelry with complex geometries. Aerospace. SLA is employed in aerospace engineering to produce prototypes and models of aircraft companies such as airfoils and engine parts for testing and validation purposes. As well as medical devices. The medical industry uses SLA to manufacture prototypes and custom components for medical devices and instruments. There's a lot of potential there within the industry. I didn't realize how big of an industry it is, especially in the US. Not necessarily other parts, but in the US, there's a lot of potential there. Some lawyers told me that. I don't know. Shout out to lawyers there. Architectural models. Architects and urban planners use SLA to create detailed architectural models of building landscapes. Automotive engineers utilize SLA to produce prototypes of vehicle components such as interior parts, exterior trim, and engine components for design verification, sale, and fulfillment testing. Uh, Miniatures and collectibles. SLA is popular among hobbyists and collectors for creating highly detailed miniatures and figures and collectible items. It allows for reproduction of intricate details in a small scale model. If anyone's interested in any of that, you just be careful with intellectual property. If it's something that you're doing for fun, you need to read legal agreements, what you can do for fun, for your own use, what it would be If you would find 3D model, just do your own research. Try not to get in trouble with any of that, but there's a lot of opportunities there as well. Custom prosthetics, SLA technology used to create customized prosthetics, limbs, and other orthopedic devices. These devices can be tailored to specific needs and autonomy of individual patents. Overall, perhaps in terms of durability, there might be some, depending on the resin of material that's been used. With to most of the cases, as well as people that I spoke to, most of the resins are not suitable for any stress. So that means they can't handle anything like that, other than perhaps figures that you can put on a shelf, as far as I know. Thanks for watching. I'll see you in the next one.